solve one problem from classical mechanics of TIFR 2025 question paper. So the problem states that a ball A is dropped on the floor from the height h. It bounces up to the height h by 4 on the first bounce. Now identical balls A and B are dropped together from the height h as shown. How high does the ball B bounce on the first bounce? Assume that the coefficient of restitution between the ball A and B is 1. So ignore the size and the small initial separation of the ball. Right, so we need to find this. So we have the problem ball is dropped from the height h. On bouncing off to the floor, it reaches to the h by 4. So coefficient of restitution with the floor EF. So we know that rebound height equal to EF square into initial height. So coefficient of restitution of with the floor is given by. So the coefficient ball A is dropped from the height. Ball A is dropped from height h on bouncing off on bouncing of the floor alone. It reaches height h by 4. Right, the coefficient of restitution with the floor EF. We have the coefficient of restitution with the floor EF. So rebound height equal to EF square into initial height, or EF square equal to h by 4 by h will get 1 by 4, or EF will get 1 by 2. Two balls drop together. Ball A, if the floor first rebounds with a reduced speed and collides elastically with ball B. We'll compute the velocity just before A hits the floor, compute the velocity after the rebound. Then we'll compute the velocity after collision between A and B. Right, the velocity is before A hits the floor. We have since both the since both velocities before A hits the floor, we have velocities before A hits the floor. Since both drop from height h, they have same downward velocity. So the velocity can be written as minus root over 2gh. So after A rebounds off the floor, so after A rebounds off the floor the velocity reverses and reduces by EF. The velocity reverses and reduces by EF. So we have VA equal to plus EF into root over V0 equal to half root over 2GH. So ball B continues falling with now the ball B2 B. Now ball B continues falling with continues falling with VB equal to V0 equal to minus root over 2GH. So the collision between A and B. So the collision between A and B. Right. Since the coefficient of restitution between the ball A ball 1 perfectly elastic, the velocities after collision are given by the standard one-dimensional collision formula for the identical masses. We can write for the identical masses we can write VA prime equal to VB or VB prime equal to A. Right. So after the collision, after collision, we can write VB prime equal to plus half root over 2GH. So this is the upward velocity of the ball B after the collision. So this is the upward. So this is the upward velocity of ball B after collision. I will now compute the rebound height. So computing the rebound height, we can write HB equal to GB square by 2G, or we can write half root over 2GH by 2G whole square. So 1 by 4 into root over 2GH by 2G equal to half GH by 2G. So we will give H by 4. So A equal to H by 4 is the correct answer. Hope the problem as well as the solution is clear. So thank you for now.